So here's the question that we had a look at in class, right? And let's break this task down into smaller chunks to make it easier to do. So the first thing is we've got a circle, and we've got a circle equation. So the first thing we need to do is we need to write this equation out with the centre and the radius. So we've got x squared plus 6x plus y squared minus 2y equals 7. Complete the square for the x. Complete the square for the y. Okay, now get rid of the constants. So okay, so that is in our form: x plus something squared, y plus something squared equals r squared. And now we know that the centre is at minus 3, 1, and we know that the radius is the square root of 17. Okay, so let's mark the centre. That's minus 3, 1. Okay, so now that's the first thing. Now the second thing, then we're going to think about our tangents. Now we know that basically our equation is y equals mx. Okay, but think about the y-intercept. So what we're going to do is we're going to sub in the point r, which is 0, 6. So we do y minus 6 equals m times x. Mx plus, what am I doing? M times x minus 0. Okay, remember y minus y1 is m times x minus x1, and we've substituted our point. So now we just rearrange that. So y minus 6 equals mx, and therefore y equals mx plus 6. Great. Okay, so now we've got an equation. We've got a general equation for the tangent. Now remember, this could be any tangent because we don't know what that gradient is. And for any circle, it has an infinite number of tangents. Okay, unless we have an equation of a line, we don't know which one it is. Right. So we've got a y-intercept, but we don't know what m is. Right, so now we want to find P and Q. We want to find the points where it meets the circle. So whenever we want to find the point where two things meet, we make the equations equal to each other. So in this case, we've got a circle equation, which is a quadratic because it's squared. And we have got a linear equation, which is our tangent. So what we do is we're going to sub our tangent into our quadratic. So we're going to put mx plus 6. Okay. And then we're going to solve that equation. So now I've subbed that in. I need to expand out those brackets and collect together the like terms to make it a bit simpler. So right, so the first one's easy. That's x squared plus 6x plus 9 plus, now let's simplify this, we'll make it mx plus 5. So when I expand that out, I get m squared x squared, I get 10mx, and I get 25, and I'm going to take away the 17 to make it 0 because I want to solve that equation. Okay, so now what have I got? I have got x squared here, and then I've got m squared times x squared. So that means that I've got 1 plus m squared times x squared. And then I've got 6x, and I've got 10mx. So that means I've got 6 plus 10mx. And then I've got 9, 25 minus 17. So if I put those together, that means that I've got 34, take away 17, which is 17 equals 0. So now I've got an equation for the point where the circle meets the tangent. Okay. Now, remember basically there's an infinite number of points. So what I need to do is work out which one P and Q are. So I know if it's a tangent, it only meets the circle at one point, and if there's only one single point that's a solution, that means that the discriminant of this quadratic has to be 0. So I look at my quadratic and I say, right, A is the thing that multiplies x squared, 1 plus m squared. B is the thing that multiplies x, that's 6 plus 10m. And C is basically my constant, which is just 17. Right, so I do b squared minus 4 times a, which is 1 plus m squared, times c, which is 17, and that equals 0. So I've got 36 plus 120m plus 100m squared minus 4 times 17, which is 68. And then I've got minus 68m squared equals 0. Right, and then we collect the like terms. So I've got 100m squared, take away 68m squared, which leaves me with 32m squared. I've got 120m, so that's just 120m. And then I've got 36, take away 68. So that is going to leave me with minus, minus 32 equals 0. And then I need to solve that equation to find my value of m. So let's ask our calculator. Polynomial 32, 120 minus 32. I get a quarter and minus 4. So m equals a quarter and minus 4. Now, remember we found m. So my m values are the gradients for my tangent. So now I know I've got two lines. I've got L1 and L2. From the diagram, I can see that L2 has a positive gradient. So that means that for the equation for L2 is going to be y minus 6 equals a quarter times x minus 0. Okay, and then for L1, I know my equation is y minus 6 equals minus a 4 times x minus 0. And then I can basically find my equation for my two tangents. Remember, one's plus, one's minus. That's it. Right, try the rest.